How is the volume of a cylinder related to the volume of a rectangular prism? Think about this question during the lesson. Jenna and Ricardo want to buy a tank large enough for 25 zebrafish. They figured out that a tank with enough room for their fish needs to have a volume of at least 2,310 cubic inches. The tank they're considering is 48 inches tall and has a diameter of 24 inches. How can Jenna and Ricardo determine whether the cylindrical tank can hold the zebrafish? Remember, volume is the measure of the amount of space inside a solid figure. As you did to find the volume of a prism, fill the base of the cylinder with one layer of unit cubes, and then you can stack layers until you fill the cylinder. Will filling the tank with unit cubes provide an exact measurement of the volume?
Select your answer.
You cannot count the cubes because some are incomplete. However, you can still use the volume formula. Volume equals the area of the base times the height. Use the formula to find the volume of the cylinder. It's the same formula you use to find the volume of a prism. In this case, the base of a cylinder is a circle. So the area of the base B equals pi times r squared. Use 3.14 for pi. The diameter of the base is 24 inches, so the radius is 12 inches, and the height is 48 inches. You can use a calculator to find the approximate volume. Remember, Jenna and Ricardo's fish need a tank with a volume of 2,310 cubic inches. Is the tank large enough? Yes, its volume is greater than 2,310 cubic inches. The cylindrical tank is large enough for the 25 zebrafish. Actually, it may be too large. Now you know how to calculate the volume of a cylinder. It's the same reasoning you used before to find the volume of a prism. The area of the base of the cylinder is 78 5/10 square inches. What is the volume of the cylinder?
Base times height is part of our formula. So we have the base of this. Well, let's start with the height because it says it in the picture is 11. And in the problem, it tells us the base, 78 5/10. Now we have to multiply that. And we get 863 5/10. So the volume of this cylinder is 863 5/10.
The volume of the coconut water can is 300 milliliters, which is equal to 300 cubic centimeters. What is the height of the can? Use 3 14/100 for pi and round your answer to the nearest tenth.
The formula volume is equal to base times height. We have our volume, which they gave us, which is 300 cubic centimeters. Pi, r squared. So the pi is 3 or 1/1400ths. And then we have our radius. They show us here the diameter of the can. Top is 5 2/10, and so half of that would be the 2 6/10. So you square that, and so 300 is equal to 21 2,264 10 thousandths, and then times height. And the height is, we have to divide 321 and 2,264 10 thousandths, and you get approximately 14 1/10 as the height. So the height can be about 14 1/10 centimeters.
Safety barrels are used on some highways to cushion cars on impact. If a city manager approves the purchase of 15 cubic meters of sand, how many barrels can be filled with sand? Use 3 1400ths for pi.
Tells us to drag the tiles to write an equation for the volume of each safety barrel. So it says use the formula for the volume of a cylinder. So V is our volume, B times H. And then the base of the cylinder, and the volume, and it's pi times r squared times the height. And then you substitute the r and the h. So the diameter is 0.9. So half of 0.9 would be our radius. So that would be this. And 45 hundredths. And then the height tells us here's 1.2, or 1 2/10. And there we go. So here it is again. What we put in the tiles, and then they actually solved it. And so the volume is that very long decimal, meters cubed. Now that we're dealing volume, it's cubed instead of squared. And then step 2 is to find the number of barrels that can be filled. So there were 15 cubic meters of sand that were bought. So we have to divide that up by the amount for 1. And so when you divide it up, it's approximately 19 7/10. So they can fill up 19 fully. The 0.7 is only a portion of a 20th barrel, but it won't be completely full. So they want to know only the completely full barrels, and that is 19 total barrels.
Lynn is building a cylindrical planter with a base diameter of 15 inches. She has 5,000 cubic inches of soil to fill her planter. What is the height of the largest planter Lynn can build? Use 3 1400ths for pi and round to the nearest inch.
So our formula for volume is going to be volume is equal to base times height, right? So then now we look at information given. We have the diameter of the barrel. So we know base is pi r squared. So we have, for the radius, half of the diameter. So 15, half of that would be 7.5. Sorry, 6.5, not 7.5. So 6.5 squared times pi, and then and then we have, for our height, we don't know. So that's what we're solving for. So we're going to put our height, and then the volume is 5,000 cubic inches. So they give us that. Alright, so we've put in everything we know. Now we need to solve. So 6 5/10 squared is going to equal 42 25 hundredths times pi, which is, let's use the 3 1/4 14 hundredths times h. 5,000. Okay. So 42 and 25 hundredths times 3.14 is equal to 132 and 665 thousandths. And then that's 5,000 still over here. And that's going to be h. So now we need to solve for h. So we're going to divide by the 132 and 665 thousandths on both sides of our equation. Okay, that cancels out. So we have h is equal to, let's see, 5,000 divided by 132, 665, 37, and a really long decimal, but I'm not going to write all of it. I'm going to round to the nearest inch, it says. So the nearest inch will be the nearest whole inch, so 38 sounds good to me. And so the height will be 38 inches total. So I checked my work, realized that I made a mistake, and I corrected that mistake. I was right the first time. I said it was 7 5/10 as the diameter, and I second guessed myself, but the work is still the same. So I changed all of my answers so that you can see the correction that I made. So the answer for the height is 28.